Hey Ayush, this is Mr. Caslin. I wanted to just give you a quick example of one of these total force problems that you had in your packet. So the idea of this is kind of a physics problem. You've got a block here and it's being pulled by two different forces, or more exactly pushed by two different forces. So you've got one force going in this direction, 30 degrees from the horizontal. Now N, I believe, in this problem is going to be your units. So you have a 4 Newton force in this direction. You have a 4 Newton force in this direction, and you're trying to find out if both of these forces are pushing on this block, what angle is this block going to move with what force. So we're expecting the two forces combined will probably push it in this general direction, and the force is probably going to be greater than 4 newtons. Okay, so to set up this total problem, let's figure out the vector for this first force. So what you do is you take the magnitude of the force, and you're going to do cosine of the angle, which is 30, and sine of the angle. Apologize, I'm not writing with a mouse, which it's not too easy for me. Okay, now you have force 2. We're going to create a vector for that. That also has a magnitude of 4. Now the angle, you want the angle from 0, which in this case would be 120. So you've got cosine of 120 degrees. Sine of 120. Okay, you're going to distribute. Now your teacher may want you to do these in fractions like 1/2 and square root of 3 over 2. To get through this more quickly, I'm just going to do decimals. So 4 times, for example, the cosine of 30. Well, cosine of 30 is 1/2. Is this square root of 3 over 2? So decimals, it comes out to your vector 1 is 3.46, and then 4 times 1/2 is 2. Right? You have vector 2. 4 times the cosine of 120 is going to be a negative 1/2. So you've got negative 2. And again, another square root of 3 over 2 times 4, which is 3.46. Okay, now you're going to create a resultant vector, meaning these two in combination. So just add your x's. Add your x's, and somewhere I've done this, well, that's easy calculation, 1.46 and 5.46. So this is considered to be a resultant vector, and you can find your magnitude and your direction from these numbers. Remember, magnitude is basically Pythagorean theorem, square root of this squared plus square root of that squared. I believe when you do that, you're going to get a magnitude. So again, square root of a squared plus square root of b squared, and you're going to get a 5.65. And remember, our units was newtons, so we expected this new force to be larger than the individual forces. Now we need a direction. We need to know what direction this is going in. So remember, if you've got an x and a y, you're going to do inverse tan. So the arctangent of y over x, which is 5.46 divided by 1.46. You do the arctan of that, I believe you're going to get a 75 degrees. Okay, so this is your formula for the individual vectors. Create your two vectors, and then you're going to add those together, get a resultant vector, and then you know your magnitude and your direction from those. So 75 degrees, if that's 97, so the new force basically looks like that, and it's going to be 5.65 newtons. So again, that's the resultant force when you have two different forces pushing on this block. Okay, I hope that makes sense. Now you were asking about directions of angles. I'm not sure, see if I'm answering your question, but let's do a more basic problem. So if you're given the coordinates, let's try -4, 3. I'm sorry, let's do 3, -4. And let's look for the direction of the vector angle. Let's extend this down. So we've got 3, -4. So like you're doing in trigonometry, here is your 3, -4, and we're looking, what we're going to calculate is this angle. Okay, so again, you're using your arctan, your inverse tangent. It's always y over x, so -4 over 3, which I believe is going to give you a angle of 53.13 degrees. Now notice this is in the fourth quadrant, so when your teacher was saying what's the positive angle, so if we're starting from 0, we're moving around to the fourth quadrant. So in this case, you're going to do 360 minus the 53.13. You'll get a, what's that going to be, 306.87 degrees. So depending on what quadrant you're in, convert that to an angle from 0. Okay, so in some cases you may be subtracting from 180, some cases you may be subtracting from 360. Okay, so here was your resultant force problems, and then here's just your basic find a vector angle. Okay, hope this helps. I'll send this to an email, and then if you can scan and send me additional problems if this did not answer your questions. We will talk to you next week.